So this is my overall summary of the molecular geometry of sulfur dichloride, or SCl2. We can start off by looking at the 3D model I made for the molecular shape of the molecule. The first thing that we notice is that sulfur is a central atom, and the outside atoms are actually two Cl's bonded to it, so we see the SCl2. The long sticks represent the bond pairs, and then we have two smaller sticks at the top that represent lone pairs at the top of the sulfur atom. Now, if we add these up together, we have 1, 2, 3, 4 groups of electrons. Now, four total pair of electrons mean that it falls under the tetrahedral family. The only issue with this is that the tetrahedral family mean a traditional case of Vesper notation of AX4 would mean that there are 4 molecules bonded to one central atom, but this actually has two atoms bonded to the central, 2 other atoms bonded to the central atom, and 2 lone pairs at the top. Now these 2 lone pairs actually cause repulsion, and they distort the traditional tetrahedral shape, which means that the bond angle actually becomes less than 109.5. Now, in terms of this distortion of the tetrahedral shape is what makes it a bent shape, and that's the molecular shape of the molecule. Now, when it comes to the orbital hybridization, it's still sp3, as with all the other molecules in the tetrahedral family, and for this Vesper notation, it's actually AX2E2. Now, when it comes to the shape, we can see that another prime example very close to SCl2 with a very similar molecular shape is actually water, with the 2 other atoms bonded to the central atom and 2 lone pairs at the top. So we can see that the bond angle between water is 104.5, and this actually is very close. It's less than 109.5, but it can be rounded to close to 104.5. Now, when it comes to the polarity of this molecule, it actually is a polar molecule. Now we see that Cl over here has a electronegativity of 3, where sulfur has an electronegativity of 2.5. Now the difference in electronegativity means that there is a net dipole facing toward chlorine, facing toward the chloride, which means that sulfur is left slightly positive and chlorine is slightly negative. Now that difference in electronegativity is 0.5, which means it actually is a polar bond, and the molecule itself is asymmetrical, right? So this would qualify the molecule as polar. Now when it comes to a polar molecule, that means the strongest intermolecular force here can be dipole-dipole attraction.